He's the project and vertical account manager of Greene to share the expertise of their company in waste valorization. Please, Carlos, the floor is yours.
Thank you very much, Adrian. It's a pleasure and a great opportunity to share what Greene Waste to Energy is doing now for all these kind of things related to circular economy and waste to energy in this case. Can you see my presentation, right? It's okay? Okay, first of all, let me just start with a sentence that it's a quick summary of why we are here. And this is a sentence that I read somewhere and I think is very impressive. It says something that this is the first generation to, sorry, this is, we are the first generation to, let me check. Sorry, we have some problems in the, right, to experience climate change, and the last one capable to do something in order to minimize its consequences. This is quite shocking because it's absolutely true. And it's, again, a very good summary of everything that we are talking today in this important session. My company, Greene Waste to Energy, is a Spanish private company created in 2011, specialized in organic waste valorization in two different ways. First one is material valorization, and the other one is energy valorization. We are owners and licensors of thermal conversion technologies created by ourselves. Our headquarters is located in Spain, in Elche, close to the Mediterranean Sea, in Alicante province. And currently we are working here, 60 people in all the phases of our industrial project, from engineering, construction, and finally operation and maintenance. This is the growing of the company from the very beginning, from 4 people to 60 roughly today. So we are very proud of that. This is basically what is the business that we are going to develop. We have several projects nowadays, which are basically based on the treatment of solid waste for the paper industry. The first project is in northern Spain, and we are developing and constructing a second plant from processing solid urban waste, municipal solid waste, in southeastern Spain. Both plants, the goal is to be operated in 2022. Our current business model is based basically on a total responsibility for invest, build, operate, and maintenance of the whole plant, of the whole project. Our plan is to operate in the next 10 years around 100 gasification plants in Spain and Europe, and probably we are going to expand our capabilities to South America and hopefully to Asia. We are committed to offer to client partners a more long-term, cost-efficient and sustainable solution to manage waste, contributing to reduce the environmental problem, waste disposal, within the circular economy scenario, generate energy, and reducing the carbon footprint, improving the corporate social responsibility of companies. In addition, Greene aims to invest and co-invest with partners in its own projects, which meet environmental, social, and governance criteria and offer very attractive returns from shareholders. Basically, these are, in the first part of the slide, these are what are the main raw materials that we use as residues. We use this 5 types of residues as raw material for material and energy valorization or energy valorization. We can process a wide range of organic wastes, but it's very important to clarify that we are treating only the rejected fraction after recycling or reuse, right? So the rejected fraction, which is a normative directive, is the only raw material that we are going to use in our plants. We briefly use 5 types of wastes. First, municipal solid waste. First, industrial solid waste, sludges from wastewater treatment plants, plastics, and biomass. Okay, this is our main raw materials agenda. In the other hand, the products range we can offer is basically, the first one is syngas, synthesis gas, which can be used as energy source or raw material for other different materials, high value materials. Also, we can obtain pyrolysis oil, which can be commercialized as green fuel. Our syngas also has a very interesting percentage of hydrogen that could be purified and sell as pure hydrogen. Then we have another subproduct, which is high quality coke, okay, with several applications. And finally, we can obtain a final product, which is some inorganic compounds. For example, calcium carbonate, usable for civil works, concrete, asphalts, everything. The main technology point for green is that we can break down the whole process into few steps. The first step being a drying process. Second is a pyrolysis process. Third is a partial combustion in a cracking chamber. And finally is the gasification itself, okay? In this slide, you can have some more details, but I don't want to be more detailed than that. You can have the presentation. So, and if you have any question, please don't hesitate to contact me. Why the technology offered by Green is so innovative? Basically, the previous reactions, pyrolysis and gasification, are two very old and quite used in chemical industrial plants, but always as separated processes. Okay, the green step forward is to integrate both reactions into one single process with two reactions in series. That's the main point, and this is the step forward for greening. The solid product from pyrolysis, it is called char, which is basically coke, is fed to the gasification reactor. The typical gasification reactor feed was the biomass, the waste. Not in this case. In this case, the gasification is fed by the coke coming from pyrolysis. This is the main difference. By doing that, green process minimizes weak points and optimizes main advantages of both reactions, taking the best of both reactions, okay? And just as a brief summary of what are the main advantages that the green process has versus incineration, common normal incineration, is that material and energy valorization is possible, both. So, in the case of incineration, only is usable for energy generation, not material generation. The green process yields a higher energy efficiency due to integration of both reactions. Besides, due to process conditions, which are high temperatures and low oxygen atmosphere, contaminants formation is reduced or avoided. For example, NOx, SOx, dioxins, and furanes. The green process implies a CO2 reduction, obviously, And one of the most important characteristics of our process is that it's feasible for small and medium scale, which is not applicable for incineration. Incineration, a part of the environmental issues, is not applicable for small or medium scale, only for big plants. This is a quick sketch diagram, P&ID diagram for our process. More detailed description of any step of the process. The pictures are real pictures from a real plant. And these are basically what is the commitment of Greene from environmental point of view. First, to be a sustainable, smart, and profitable alternative to, first, landfills. Landfills is planned to be banned around 2030 or 2050 directives. Secondly, it's an alternative to incineration process, which are to be replaced by sustainable technologies as soon as possible. Second goal is to reduce CO2 emissions in several ways, basically three ways: CO2 avoided by suppression of landfills, CO2 avoided by suppression of incineration process, and finally, CO2 avoided by reduction of transportation and logistics, because the waste storage is close to our plants. So we are reducing transportation cost. Finally, because the process conditions, we are trying to avoid generation of highly toxic substances, as I said before, dioxins, furanes, as usually are formed in normal classical incineration. These are some figures for having a magnitude of what is the reduction of CO2 formation. Basically, these are for different projects, for different wastes. But in the case of sludge coming from wastewater treatment plant, we can avoid around 30,000 tons per year of CO2 in the maximum case. Okay. Obviously, this has not only an environmental value, but also a economical value. We can save around $2.7 million per year with this particular technology. These are the 7 bases of our technology. We can process any kind of waste, heterogeneous waste, wastes with high ash content, meaning with high inorganic content. We can manage condensable volatile matters like oils and tars. Our process is full autothermal. We don't need any external energy input because all the energy inputs are coming from the process itself. We have another advantage in size and flexibility of plants. And the plants, once they are start up, they are standalone operation with very, very, very easy operation.
Carlos, if you could wind up in 2 minutes, please, so that we can give some time for Q&As.
Okay, 2 minutes will be enough for me.
Thank you.
Our main product, as I said before, is syngas, and here you have some slide summarizing potential applications of the syngas, right? Power generation, hydrogen generation, methane generation, and also in the right side we can use Fischer-Tropsch technologies to generate more products of high value, and even a methanol synthesis line, which is very important nowadays. This is a composition of the syngas, which, as you can see, we have around 15%, okay, of hydrogen, which is quite important percentage. This is the table showing the main characteristics of our technology. You can check later. This is our portfolio of future products with some estimation of the year that we are going to reach it. And finally, let me show you some R&D projects that we are developing currently in Greene: hydrogen frozen gas, biomethane upgrading for reinjection in the Spanish natural gas pipeline network, biochar for different applications, pyrolytic oil upgrading to obtain, for instance, BT extraction, benzene, toluene, and xylene, and naphthalene, and the development of the pyrogenic vinegar, which is the aqueous fraction coming from pyrolytic oil, for extraction of high-value chemicals such as benzoic acid, acetic acid, and jet fuel additives. So thank you very much for your attention. It has been a pleasure. And here you have all my address and coordinates just to contact me. Thank you very much, everybody.